Hello again, everyone, and welcome back. Before I introduce our next speakers, please remember the conference close was going to be in the Curly Boy Theatre, so that's the room just above this one in Venulus. So don't go anywhere except for that room after Q&A, and we'll have the conference room and a nice time there. But next up, we've got setting up a machine translation service for Timor-Leste with Rafa Merks and Mel Mystica.
Hi everyone, thanks for coming to our talk. We'll be around for Q&A after the talk, and also we'll be online as well, so please ask us questions. Thanks very much.
All right, hello everyone. Today we're going to talk a little bit about how we set up a machine translation service for Timor-Leste. So machine translation service is a fancy natural language processing term to mean something like Google Translate. So a service that would translate sentences and whole articles. And we set up a new one for a language that is not supported on Google Translate or Bing Translate or any other free online machine translation service. So this was entirely set up as a volunteer project. You can check out the product of our work at tetun.org. We've got a website, tetun.org, and we also have mobile apps for Android and iOS. And together, the website plus apps have around 10,000 monthly active users, and it's growing fairly quickly. All right, a little bit about us. So I am Rafa. I am the head of governance and transparency at Catalpa International. Catalpa is a technology for development sector NGO. You can check us out at catalpa.io. And then we have Mel. Mel is our resident NLP expert, and she is a language data scientist at the University of Queensland. All right, so we're going to start with a little bit of background. Where is Timor-Leste? What is the Tetun language? Why it's important in Timor? And then Mel is going to take us through the theory fundamentals of our project and how we can approach it. Then I'm going to talk a little bit about how we did it in practice, how we gathered the data, trained the model, and published it. And then Mel is going to conclude with some future interesting work that we can set up for tetun.org and some of the usage statistics. All right, so a little bit of background. Timor-Leste is a half-island nation. The other half of the island is part of Indonesia. And Timor-Leste sits around 500 kilometers north of Australia. It has around 1.3 million inhabitants and got its independence from Indonesia in 2002. Now, it's very linguistically diverse. A lot of people speak several languages. Sometimes people speak a very local language and speak Tetun, and might also be able to speak Indonesian or Portuguese or English, depending on their background. But among all of these languages, there is one that stands out, and it's the Tetun language. So foreigners like me who move to Timor-Leste and live there will usually learn Tetun so that they can speak with the local population. And Tetun is really the lingua franca of the country. So for example, in the streets of most cities, you will be expected to speak Tetun. A lot of people who don't share the same local language, even though they speak their local language at home, they will speak Tetun with each other. Similarly, Tetun is the most spoken language in the media, in politics, etc., etc. So it's definitely a language of high importance in Timor-Leste. Despite that, like I said, it was not on Google Translate or Bing Translate or any other widely available translation service. And so what this means is that for me, a person who is trying to learn Tetun, I can find words in individual dictionaries, but if I find a whole sentence, I don't have an easy way to translate that whole sentence in Tetun to English. Similarly, a Tetun speaker that doesn't yet master English, if they find a whole article in English, they don't have an easy way to translate this article into Tetun. Or if they have a sentence that they are most comfortable speaking in Tetun and they want to translate that sentence to English, there's no easy way to do this until we set up this new service. All right, I'm going to leave you to Mel, and Mel is going to take us through the fundamentals of our project.
Thanks for the great summary of the context in which Tetun is used, Rafa. So given the diversity of the linguistic background of the country, we thought it would be great if there was a machine translation service in Teton that was freely available for anyone to use. When we decided to embark upon this project, we asked ourselves a couple of questions. What resources did we have, or what resources could we quickly and easily develop ourselves? And what was required to build an MT system? So obviously, the resources we needed would depend on the kind of system we wanted to build. For example, some of the earliest systems were symbolic systems that were rule-based and required a bunch of rules and lexicons. So here, these kinds of systems were made up of three components: a set of rules for analysis, a set of rules for transfer or correspondence rules, and a set of rules to generate the source language. And actually, there were very few resources that were required to just get it up and running. One of the very first systems from the 50s only had a handful of rules and no more than a couple of hundred words. So these kinds of systems were great for a very limited domain, and they were very quick to get up and going. But beyond the rules, the few rules that were developed, and the very limited number of words that it could analyze, these were not very robust systems, not to a wide variety of inputs. So they were quite brittle. From the 1990s onwards, the main area of research for machine translation was statistical machine translations. These kinds of models comprised of two components, the translation model and the language model. The language model here in purple is trained on vast amounts of monolingual data. And it's the part of the model that's responsible for a fluent sounding output. The translation model is learned from parallel text, and often millions of sentences. So it's very resource hungry. So it's not shown here in this formula, but part of building this kind of system, part of developing this kind of translation model, also required modeling the best word alignment between the source and the target language. So here the source input is denoted by X, and Y is the target output. And in order to learn a good translation model, we required lots and lots of parallel data. So after 2014, we then experienced the next big seismic change in machine translation with the use of neural models. So we'll talk about neural models a bit more later, but first I just want to return to our resource issue. So we had only started with an idea of building an MT system with no other resources. We had no available parallel corpora. We looked and there was nothing available, but we did have dictionaries that we could repurpose. However, having a brittle system was not that appealing to us. It would require, building this kind of MT system, a symbolic MT system, would require the help of many linguists who knew how to code and who were possibly proficient in both languages. But going down the SMT path would mean building our own corpus, and this brought other issues. So if we were to create a corpus for an SMT project, we wanted to be able to have the kind of translation system that reflected standard Tetun. So this would limit what kinds of texts we could include. So it meant that we couldn't include some sources that were too formal. The other issue that we had was that even though you had texts that were bilingual, often these texts are not completely parallel, and so would have to be thrown away. Okay, so popping back to talking about the different types of MT systems, in 2014, we were introduced to a new way of doing MT using neural networks. Before 2017, we had sequence-to-sequence models or seq-to-seq models. And these seq-to-seq models were end-to-end models that comprised of two components, an encoder and a decoder. The encoder handles the input sequence and produced one encoding or one representation of the whole entire input sentence. A decoder was then responsible for generating an output based on the encoded input. So it's a conditional language model that's conditioned on the encoding of the input. Okay, so cut to 2017, where we had attention-based neural networks introduced to us. So this brought about significant improvements in NMT. So this was great because we weren't just relying on how well the encoder represented this one input. The decoder could focus on specific parts of the input that it was currently translating. So it wasn't as though the encoder was responsible to just create this one representation. The decoder was a language model that was conditioned on the input, but at different time steps. In essence, it was a more elegant solution to SMT's word alignment problem. So given these advances in NMT, we thought that we would try our hand at implementing an attention-based model from pre-existing and publicly available tools. And Rafa will now go over this and let you know how we went about that process.
All right, thank you, Mel. So now that Mel has given us the theory fundamentals of how we are going to approach building our machine translation model, I'm going to take you through what we actually did in practice. So the first step is going to be gathering parallel English Tetun text. What you find in the wild is usually not parallel sentences, which is what you want to train a model, but you'll find parallel articles. So in our example, there is a wealth of websites that publish content in both English and Tetun. For example, the government website, the UN, some NGOs, think tanks. There's some educational books as well. And so we set out to scrape a bunch of this data and then gather it. And then try after this in the next step to actually create parallel sentences from it. So this is the example you see here on the right-hand side of this slide, where this is an article published on the official government of Timor-Leste website, both in English and Tetun, about Timor-Leste receiving 65,000 doses of the AstraZeneca vaccine from Australia. Once we have these parallel articles, we need to find parallel sentences. And it's not always obvious, right? The same paragraph in English and Tetun might have a different sentence count. Sometimes there's one paragraph in English that was never translated to Tetun or the other way around. And so you need to have some guesswork at this stage. So the kind of tool that you use here is called a sentence aligner. In our case, we used Hunalign. And what you do is that you feed to Hunalign parallel articles. You also feed to Hunalign a dictionary of what Tetun word corresponds to what English word. And then Hunalign is going to use this information to try to guess which sentence in Tetun corresponds to what sentence in English. And so, of course, at this stage, you throw away some sentences, right? Honeyline gives you a confidence score for each one of the sentence pairs, and we try to adjust the threshold that we used here so that we would not discard too many sentences, but so that at the same time, the quality of the sentence pairs was pretty good. So now that we have our initial set of sentence pairs, we are still going to have to clean them up before we feed them to the model. And this step is actually fairly important because you could have different Unicode representations of the same text. You will need to remove like non-printing characters that might confuse your model. Another thing that was of really high importance for us was standardizing spelling. So this was especially true for Tetun, although it was also true for English, for example, like UK versus American versus Australian spelling. But for Tetun, even though there is a government mandated spelling out there, sometimes people will not use it. And so this is the case for the word you can see here on the right. The word nebe means which or where in Tetun. And the form at the bottom with the apostrophe and the accent is the government mandated form. But the forms at the top that you can see here are also used in the wild. And so we need to standardize all of these forms to the accepted government spelling. And there's two goals here. One is because we want our model to use the correct form of Tetun. And the second goal is because it's actually going to make our model smarter, because it will not confuse our model to see these different forms of the same word and try to have to guess between which form is the right one. Okay, after this we apply tokenization, so separating each one of the word by a space, and also the punctuation has to be separated from the text by a space. And then we split all of this corpus into a training set, a validation set, and a test set, and we're ready to test. We're ready to create a first model. So what did we use to train the model? So this is going to be a neural network, and so we will need a GPU to train our model. In our case, we actually used Google Colab Pro. It gives you a notebook, and if you pay for the Pro feature, which is really cheap, it's like $10 per month, you actually get a fairly good GPU oftentimes. In our case, I think we got P100 GPUs, which were more than good enough for us. I think the whole model takes like around half a day to be trained. And the library we use is called FairSec. So this is really the core of the model training here. FairSec is a toolkit built by Facebook AI on top of PyTorch that is specifically for sequence-to-sequence models. So in like machine translation models are a sequence-to-sequence, like a sentence is essentially a sequence of tokens, and then the output is also a sequence, is also a sentence, which is also a sequence of tokens. FairSec has examples out there of how you can use FairSec to create your own machine translation model, and so and has ready-made architectures that depend on what you want to do and also on the size of your training data. All right, so after this, we created a first model. The quality was pretty poor, but it was clear that if we improved it, it would be more than enough to be useful. So at this stage, we just iterate. Essentially, iterating means getting feedback from actual real Tetun linguists that you let them try out the model, and then they can point out, oh, this is not working like it should, this is fine, etc., etc. Trying to track progress during training using TensorBoard, see if it overfits, is the validation set overfitting, is the training set overfitting, etc., etc. And like I said before, more spell checks and more standardization. In our case, it really made the model a lot better. All right, so by the end of the model training, I think there was something like 15 or 20 iterations. We actually had a model that was of fairly good quality. Like, Google Translate for moderately well-resourced languages will have a BLU score of around 40. And this is also what we had for our model, where we had, I think, 38 BLU score from English to Tetun and 40 BLU score from Tetun to English on our test set. So we were pretty happy with it, and trying it out on various articles, in both directions, we could see that it was useful, that it was getting the gist of the article, and that people could actually use it to try to get the meaning of especially a language that isn't theirs. So now that we have a model of fairly decent quality, we serve it using a Django API. So the model is loaded by FAIRSEC, but this load is happening inside of a Django endpoint. In our case, Django REST framework, only one endpoint, 3 parameters for the endpoint, the text, which is a series of sentences, the source language code, the target language code, and everything it does is, split the text into a bunch of sentences. For each sentence, apply the preprocessing we applied for cleaning up the corpus, so also the spell checks, etc. And then translating each one of these sentences individually using our FAIRSEC model and responding to the request with that translated text. That API is used in turn by our front end. So in our case, this is a website and mobile apps called tetun.org. I had actually created them before for just a simple English Tetun dictionary, and a fair number of people were using it already, and this was just a translate feature that was added to these existing front ends. But you can see it all here on the right-hand side. It's essentially like a simple Google Translate. You enter a sentence in English, click the translate button, and then it gives you that sentence in Tetun.
As Rafa just mentioned, the site that hosts the current machine translation service used to only be a bilingual dictionary lookup service. Since putting up the translation service, the core number of active users has more than doubled. We get around 2,500 translations per day, with around about 10,000 active users per month. The people who normally use this service are people who translate reports or students of the language translating everyday interactions. We're now thinking of the next steps on how to improve the quality of the translations for those who use the service. While we're able to translate reports sufficiently well, where we fall down is translating everyday conversational language, because our original constructed parallel corpus was not trained on this kind of language at all. So one way to remedy this, of course, is to include this kind of conversational style as training. In terms of different techniques to improve the overall translation quality, we wanted to explore ways that we could improve the quality of translation without the reliance of manually constructing parallel corpora, because this is an expensive task. One of the avenues we wanted to pursue was using more monolingual data by applying a back translation method. This is where we train the system to predict the original sentence from our system's translation. So effectively, we're creating like a synthetic parallel corpus. So please keep in touch with us via the website so you can track how we're faring in this endeavour. Thanks very much for attending our presentation. We hope you enjoyed us taking you on our journey in creating this MT service for Tetun. Thanks.
Thank you so much for that talk. Before we welcome them back to do the Q&A after the session, I'm just going to remind people that after this Q&A, there is a conference close session in the Curly Boy Theatre just above the Platypus Hall. So don't go anywhere except for that room after the Q&A is done. Cool. That went really well. So we've got several questions with votes on them in the thing. We'll go for the first question first, which is what sort of sizes of corpus do you need for language model and translation model that you require?
Mel, do you want to answer that?
May need to unmute in StreamYard. Yeah.
Sorry, do you mean if we went for the SMT method rather than the neural method? Because usually you need millions and millions of parallel corpora for that. But Rafa, we only had about 120,000 sentences. Is that right?
Yeah, that's right. That's right. And it's for Tetun, it was enough. It depends on the size of the vocabulary. So depending on whether languages have a very wide vocabulary or not. In the case of Tetun, like each word has usually only one form, apart from some words that come from Portuguese. So I guess it's very possible that if it was like Romanian or German, it wouldn't have worked as well with such a small corpus, but it happened to work fine for us.
That's interesting. Cool work for a low resource language. Have you tried using embedded based metrics, e.g. BERT score?
Have we? We haven't.
No, we haven't, but maybe, yeah. Yeah, I mean, yeah, we could, rather than using Blue, we could use BertScore. That's really what BertScore was invented for. So, yeah, thanks for that suggestion. This was kind of done on a shoestring as well. So actually, Rafa and I met via somebody that I met via Facebook. So Rafa and I have never actually met each other in person. We just kind of thought it would be really nice to have this resource, seeing as it wasn't available.
Yeah,
That's really
there's
cool.
1,000 things that we could do, that we could try if we had unlimited time. And this is one of them. And there's so many others, like back translation, etc., etc. It's just not enough time.
We've got another question, which is, how much do you estimate the entire system cost?
I mean, the Django is on a DigitalOcean droplet. I think that's $10 per month. And then that's it. The front end is served using Netlify. That iOS app is costing me like $100 a year because of the Apple developer fee. That Netlify, the usage is low enough that it's still free. And then there's the domain. So you can say altogether, yeah, maybe $250 per year, US.
But it also costs a lot of love. We put a lot of love in it too.
It did. It costs way more time than it costs money. That's for sure.
Yes,
Yeah.
Absolutely. I'm not sure if we answered this in the talks, but we've got, what help do you need going forward?
It's really just time. And actually, we have to try to figure out if we want to make sure that we can accommodate this conversational sort of language. Like, we kind of have to be a bit picky about how we're going to construct that corpus, because we don't want it, like we said, we wanted to have more standard language, but conversational language is really quite informal. So how can we stick to standard language but still kind of have sort of that sort of type of conversational style. With blogs, sometimes you're gonna have like spelling that we don't want. So Rafa was actually, you started looking at more informal kinds of corporate, and that we sort of decided to throw out. Did you want to talk a little bit about that, Rafa?
Yeah. This is really something that we would need to look for. So for example, we don't have any other data coming from places that have informal speak, like Facebook, for example. But it exists out there. Like there is a bunch of people posting on Facebook using Tetun, and probably they use a more informal language than, say, a government website. So this is what I would start looking into. We haven't had the time to do this, but trying to find sources that have more informal language, and then trying to integrate that, and then set up a test corpus of, this is some informal sentences, and we already know their translation. Probably the model doesn't perform well on them now, and try to, feed some more informal sentences to the model and see how it adapts. Hopefully it doesn't lose quality on the formal speak, and hopefully it gains quality on the informal speak. It's definitely one of the things that would be high priority. Apart from this, there's many things that would be interesting to do, like, like even just outside of machine translation, like trying to have a speech-to-text transcription for the Tetun language. Like, that's not something that anybody has, and it would be useful to a bunch of people. Trying to, use data, like add more languages apart from English. Like, for example, add Portuguese and Indonesian. Like, I regularly have people reaching out to me over that Facebook page we have for the service saying, hey, can you add Portuguese? Can you add Indonesian? And I've tried a little bit, and the quality wasn't good, and I kind of gave up for lack of time. But these are really things that if we added, I know there's people out there who would use it.
Yeah. We've got several questions and only time for one more question left. So I think we'll pick the next highest voted one, which is what is needed to get this translation service added to Google Translate or other big translation platforms?
So I reached out to a product manager from Google Translate like before we started working on this, saying, hey, it would be really, really awesome for the country if you could add this language to Google Translate. I was in touch with the Ministry of Education, and they were the people saying, hey, can you figure out some way to reach out to Google? Anyways, so reach out to Google. And then the product manager responded saying, we're essentially focusing on the languages that we already support, trying to improve the quality of translation for these languages. And even if they wanted to add languages to their list, I mean, I don't have a ranking of languages by number of speakers, but I'm assuming if they have 100 languages now, the 100th language still has many, many, many more speakers than Tetun. And so even if they had added another 100, it's possible that Tetun still wouldn't be in that batch. So essentially it's, I mean, Google has priorities. I can understand they put a high priority on languages that have a lot of speakers. And so it's not their priority at the moment. That being said, he did mention that if we have to the order of like 1 million parallel sentences, they could start looking into it. But I mean, we are one order of magnitude lower than this. So I'm not sure we can find, that many more.
Yeah, that's rough. Thank you so much. We have more questions, so I'll put them into the Platypus Hall text chat. As Jack has said, please don't go anywhere after this. The conference close is in Curly Boy Theatre very shortly after we finish, so head over to the Curly Boy Theatre as soon as we finish up here. And we'll have some lovely closing up and thank yous and recaps of the dates. Thank you so much for being here at PyCon AU 2021.
Thank you, everyone.
Thanks.
Bye.
Bye.